Hi, Golden Achievers! My name is Sir Arnold M. Reyes, and for this video, we will be talking about Mathematics 7, solving word problems using the Venn diagram. So for today, enable for you to better understand how to solve word problems that involves Venn diagram, let us first define what a Venn diagram is. When you say Venn diagram, it is a visual representation of the relationship between and among sets that consists of overlapping or non-overlapping circles inside a rectangle, where circles represent the different sets and the rectangle represents the universal set. Each set is described by a shaded region of the diagram. I have here a rectangle, where this rectangle represents the universal set, meaning this set contains all the elements of all related sets. And here are our two circles that represent our different sets. We have circle A for set A and circle B for set B. Enable for you to better understand how to solve word problems that involves Venn diagram, here are the lists of words that we could associate with the set operations. We have the union, intersection, difference, and complement. Let us start with the union. We can associate union whenever you see the word or. While for intersection, we have and, both, and all three. For difference, we have but not and only. For complement, we have neither nor, neither, and but not. Let us have the examples. Let's say we have here the given T, which denotes Twitter, and F, which denotes Facebook. How are we going to represent Twitter and Facebook? Since the word here is and, then therefore, this must be represented by a set operation, intersection, followed by our denotions. For T for Twitter and F for Facebook. Then we will write it as T intersect F. Next would be Twitter or Facebook. So since the word here is or, and we can associate the word or with the set operation union, then the operation must be a U, which denotes union, and followed by our denotions, which are T for Twitter and F for Facebook. Then our expression will be T union F. Next would be Twitter only. Then, since we have here the word only, and we can associate the word only with a set operation difference, then the operation must be difference or minus sign, and then followed by our denotions, where we have to subtract F from T. Then our expression will be T minus F. Next would be Twitter, meaning we should only represent this with its denotion, which is the capital letter T. Let us now have another set of examples. Let's say we have here T that represents Twitter, F that represents Facebook, and I that represents Instagram. Now, how are we going to represent Twitter and Facebook, but not Instagram? Enable for us to represent this in a set expression, then we need to first identify what are the set operations involved. So we have here the and, which is being represented by the intersection, followed by but not, that is being represented by the difference, followed by the denotions, T for Twitter, F for Facebook, and I for Instagram. Then our set expression will be T intersects F minus I. How about this one? Neither of the three. Neither is being represented by the complement, followed by the three. Now, how are we going to represent the three? Meaning this is the combination of Twitter, Facebook, and Instagram. And when we say Combination, meaning we have to unite all of those three. Then we can represent of the three as the union of T, F, and I, or T, union F, union I. And then writing it correctly in a set expression, this will now be T, union F, union I, prime. Next would be all three. How are we going to represent this using the set expression? According to our words that we can associate with the set operations, all three can be represented as an intersection, meaning we have to find the intersection of our three sets: Twitter, Facebook, and Instagram. So this is the set operation that represents all three. That would be T intersect F intersect I. Another. How about Instagram and Facebook, but not Twitter? This is a similar example just like a while ago. Instagram and Facebook, but not Twitter. So we have two operations here. We have the end, which is being represented by intersection, but not, which is being represented by the difference. Then we just have to write the denotions. I for Instagram, F for Facebook, and T for Twitter. And then our set operation will be I intersect F minus T. Let us now apply the skills that you have acquired from this lesson to a word problem. Let's say we have here a word problem. A class of 25 students in Malabanias Integrated School were surveyed and asked if they have a brother or a sister. 8 students said they have only a brother. 6 students said they have only a sister. Another 6 said they have both a brother and a sister. And 5 said they don't have a brother or a sister. The first thing that you need to do enable for you to represent this using the Venn diagram is to write all the information that you have gathered by reading the problem. And we have the total number of students would be 25. And there are 8 students who said that they have brother only. 6 students who said they have sister only. And 6 students who have brother and sister. And finally, we have 5 students who have no siblings. After writing all the given, you are now ready to illustrate the Venn diagram that represents this problem. So we have here 2 sets. We have the sets of students who said they have a brother only. And the second set, which is the set of students who said they have sisters only. So in Venn diagram, we have to use 2 circles. Kick this universal set off by writing the total that represents the universal set, which is 25. After writing the cardinality of the universal set on our Venn diagram, we can now start plotting our numerical information. Usually, we start on the middle part of our Venn diagram, which represents the intersection. Just like what you have learned a while ago, intersection can be represented by the words and, both, or all three. Then, here on our given, the only information that we have here that should be represented by the set operation intersection would be has brother and sister, which has 6. Then we should write the numerical information 6 to represent the intersection on our given Venn diagram. Then followed by this portion. And this is S only or sister only. And followed by this portion, which is being represented, which represents the sisters only. So we have here, basing from our information gathered from the problem, we have 6 students who said they have sister only. Then we have to write Then we have to write the numerical information 6 on our on the portion of sister only, followed by this area, where this area represents brother only. And according to the data that we have gathered, we have 8 students who said they have brother only. Then we should use this numerical information to represent the number of students who said they have a brother only. Followed by, lastly, we have to represent the number of students who has no siblings. And which is being represented by this shaded region. And according to the data that we have gathered, the number of students who has no siblings would be 5. Then we have to write it on the lower left of our Venn diagram. And now we have completed our Venn diagram. We are now ready to answer questions with regard to this problem. Let us have the first question. How many has brothers? Then, how many has brothers? This question is being represented by this shaded region. Then you are now ready to answer the questions with regard to this problem, but just by looking at the Venn diagram. So question number 1, how many has brothers? Brothers is being represented by set B. Then we should shade set B. And since we already have shaded set B, which contains 8 and 6, we have to add these numbers. And then we have 8 plus 6, which is equal to 14, meaning there are 14 students who have brothers. Second question. How many has brothers or sisters? And we know the word or symbolizes union, meaning we have to unite our two sets. And this is the representation of the union of set B and set S. And we have to add all the numerical information under the shaded region, which is equal to 8 plus 6 plus 6, which is equal to 20, meaning there are 20 students who have brothers or sisters. This time, let us try a word problem that involves 3 sets. We have here 60 students were asked about the online game they play. 34 students play Mobile Legends, 33 play Valorant, and 38 play Among Us. 15 of 60 students play Mobile Legends and Valorant. 21 play Valorant and Among Us. 19 play Mobile Legends and Among Us. 8 play all 3 online games. And 2 students do not play online games at all. So just like what I have mentioned a while ago, to represent this word problem into a Venn diagram, we have to write all the numerical information first. Let us start with the total, where there are 60 students who participated in this survey, followed by the number of students who play Mobile Legends, which is 34. The number of students who play Valorant is 33. And there are 38 students who play Among Us, followed by the number of students who play Mobile Legends and Valorant. There are 21 students who play Valorant and Among Us. And there are 19 students who play Mobile Legends and Among Us. There are 8 students who play all 3 stated games. And finally, we have 2 students who do not play any online games at all. Now this time, we could start illustrating the Venn diagram, where this Venn diagram consists of 3 circles that represent the 3 sets of our given word problem. We have the circle M that represents the set of students who play Mobile Legends. And circle V for the set of students who play Valorant. And finally, the circle A for the set of students who play Among Us. Let us start by writing the cardinality of our universal set. According to the given, there are 60 students who participated in this survey. And just like what I have mentioned a while ago, we always have to start on the middlemost portion of our illustration of Venn diagram, which is this one. This portion represents the intersection of all three sets, which is this given. The intersection of M, V, and A equals 8, meaning we have to input 8 on the middlemost portion of our Venn diagram. This time, we need to find out what is the numerical information that represents this region. This portion is actually a combination of the middlemost portion, which is this one, and the intersection of A and M, but not V, which is this one. If the total number of students on this portion is 8, and the total number of students who play Mobile Legends and Among Us is 19, what do you think is the number of students who play Mobile Legends and Among Us, but not Valorant, which is this portion? Very good. This is 19 minus 8, which is equal to 11 students. This time, we need to find out how many students is being represented by this region. And since we know that this is the intersection of set V and set A, then we can find out, according to our given, the intersection of V and A is equal to 21. This portion is actually a combination of the middlemost portion and the intersection of V and A, but not M. If the total number of students who play all three games is 8, and the number of students who play Valorant and Among Us is 21, what do you think is the number of students who play Valorant and Among Us, but not Mobile Legends, which is this portion? Very good. The number of students who play Valorant and Among Us, but not Mobile Legends, is equal to 21 minus 8, which is equal to 13. This time, we need to find out how many students is being represented by this region. This region actually represents the intersection of the set M and set V, which is equal to 15. This portion is actually a combination of the middlemost portion, which is 8, and the set representing the number of students of set M and V, but not A, which is this portion. If the total number of students who play all three online games and the total number of students who play Mobile Legends and Valorant, what do you think is the number of students who play Mobile Legends and Valorant, but not Among Us? Very good. This is just equal to 15 minus 8, which is equal to 7. Let us now move on to the bigger portions of our given Venn diagram, starting with the set A. This set A is being represented by our blue region, which is the number of students in this set. We still have to find out how many students is being represented by this region. This region represents the number of students who play Among Us only. Going back, the word only can be associated with the set operation difference, meaning we have to subtract. The number of students who play Among Us, which is being represented by the whole blue region, which is equal to 38, by the number of students who play Among Us and Mobile Legends but not Valorant, which is equal to 11, by the number of students who play Among Us and Valorant but not Mobile Legends, which is equal to 13, and by the number of students who play all of the mentioned online games, which is 8. And we have here an expression 38 minus 11 minus 13 minus 8, which gives us 8, meaning the number of students who play Among Us only is equal to 8. This time, we have to find out how many students play Valorant only, meaning we have to subtract the total number of students who play Valorant, which is being represented by the red region, which is equal to 33, by the number of students who play Valorant and Among Us, but not Mobile Legends, which is equal to 13, and by the number of students who play Valorant and Mobile Legends, but not Among Us, which is 7. And finally, by the number of students who play all of the three mentioned online games, which is 8. So we have created an expression of 33 minus 13 minus 7 minus 8, which is equal to 5. Then therefore, there are 5 students who play Valorant only. And finally, we have to find out how many students play Mobile Legends only, meaning we have to subtract the total number of students who play Mobile Legends being represented by the green region, which is equal to 34, by the number of students who play Mobile Legends and Valorant but not Among Us, which is equal to 7, by the number of students who play Mobile Legends and Among Us but not Valorant, which is 11. And finally, by the number of students who play all of the three mentioned online games, which is 8. So we now have here 34 minus 7 minus 38 minus 8, which is equal to 8. Then therefore, the number of students who play Mobile Legends only is equal to 8. And of course, we should not forget the number of students who do not play any of these games being represented by the pink region. And as stated on our given, there are 2 students who do not play these games at all. We just have to write it on the lower left corner of our given Venn diagram. And that's it. We are now done writing all the information needed to complete our Venn diagram. We can now answer questions with regard to this problem. Number 1. How many students play Among Us only? Among Us only contains the word only, meaning the operation is difference, meaning we have to subtract the set A minus set B minus set C, which is being represented by the blue region, which is equal to 8. Second question. How many students play Valorant but not Mobile Legends? Valorant but not Mobile Legends contains the words but not, meaning this operation involves difference. So we can represent it as the set V minus set M, which is being represented by the red region, which is equal to 18. Third question. How many students play Valorant or Among Us but not Mobile Legends? Let us first represent this question in symbols. We have here Valorant or Among Us, meaning this is the union of the set of Valorant and the set of Among Us because of the word or, followed by the words but not, which is associated with the set operation difference, meaning our set expression will be M union V minus A, and it is being represented by the pink region. So we have here 8 plus 7 plus 5, which is equal to 20. Fourth question. How many students play exactly 2 online games? When we say exactly 2, meaning this is the number of students on the intersection of 2 sets. But since we have here 3 sets, then we have the number of students who play Mobile Legends and Valorant but not Among Us, the number of students who play Valorant and Among Us but not Mobile Legends, and the number of students who play Among Us and Mobile Legends but not Valorant. And we just have to unite them. So our expression will be M intersect V minus A union M intersect A minus V union V intersect A minus M. And this expression is represented by the purple region, which is equal to 7 plus 11 plus 13, which is equal to 31, meaning there are 31 students who play exactly 2 online games. I hope you understand this lesson and see you on our next video. Bye!